Okay, to this week, we're going to talk about systems of inequalities. Very similar to, say, it's very similar to, say, systems of equations, except that we're graphing inequalities. We're going to be shading above and below the line. All right, so if we're talking about that, how can we tell if an ordered pair is a solution to a system of linear inequalities? Two ways. One is algebraically. If we have a coordinate point, I don't care which number, but what numbers, but if we have some coordinate point x, y, and we want to know if it's a solution to our system, and we're talking about to the system of linear inequalities, then we have to plug it into, we have to plug the ordered pair whoa, I'm ahead of myself in my thinking, ordered pair into both equations, one equation at a time, right? Okay. And we must get two true statements. Okay. What that means is it must make both inequalities true. It's possible that it makes one true, but not the other. The other one's false. If that's the case, then it's not a solution to the system. So it has to be true for both equations. Okay. What we're going to see graphically is we are going to shade both inequalities solution sets and look for the overlap. Okay, and you'll see what I mean about that. It's kind of like on a number line when we look for the overlap on a number line for an and. Okay, but it's not the same. It's a little bit different, and we'll see as we move along here. So let's deal with system one, example one. I've given you two inequalities, and we're going to start by graphing these inequalities. Okay, so we have two inequalities. Let's do the left one first. If I'm going to graph this inequality, the first thing I'm going to do is identify slope or y-intercept. Doesn't matter which one's first. But if I do slope, it's -3 over 1, or it's 3 over -1. Remember, this would be down 3 and right 1. This would be up 3 and left 1. Okay? And my y-intercept is 0, 2. And it's less than, so I know it's dashed. And because it's less than, I know it's below. Okay? So, not a bad idea, even though you know it's dashed and below, to use the test point. But what I'm going to do first is I am going to graph my inequality, and then I'll do the second one. So I'm going to go to y equal 2, 1, 2, and there's 0, 2. And then I'm going to count down 3, 1, 2, 3, and right 1. I'm going to count up 3, 1, 2, 3, and left 1. So I have 3 lines. It is dashed. So I will set down my ruler, my straight edge, and I will dash it. Okay. Now, there is my inequality line. I said it was below. So if it is below, then the point 0, 0 will work because 0, 0 is below the line. So if I plug in 0, I get 0 is less than -3 times 0 is 0 plus 2. Is 0 less than 2 true? Yes, it is. It's true. So now I am going to take and I'm going to shade below the line. Okay, so I'm going to shade all of this. Okay, there's my first inequality right there. Second inequality, m equals -1 over 1, or it equals 1 over -1. My y-intercept is 0, 1, and it is solid, and it is above. Now, how did I know it was solid? Because it was greater than or equal to. How did I know it was above? Because it was greater than. So now I'm ready to graph my next line. My next line has 0, 1 is my intersection point. Okay, and then it's up 1, left 1, up 1, left 1, or it's down 1, right 1, down 1, right 1, and there is my inequality. So this guy is running right there, and it's a solid line. And I'm going to use orange on this one. I don't know, I just picked up the orange pen, but it kind of distinguishes the two. Now, it's above. It gets it gets shaded above. So let's test it, though. I didn't test it, my mistake. So if I'm going to go above, let's go with 0, 2. My test point is going to be 0, 2, because 0, 2 is above the line. And let's see what happens when we plug in 0, 2. 2 is greater than or equal to -0 plus 1. 2 is greater than or equal to 1. That's true. Okay, so I'm going to shade this one above the line. Sorry to do that to you on the video, but I'm going to go like this. I'm going to shade up here all the way across. Okay, now I thought yellow and green might work, but it didn't. So I'm going to come in and show you that for this dashed line, it was everything below. So my intersection point is right here. Okay, that darker color is my solution set. All right, is my solution set. So how many of these are actual solutions? How about 4, 3? Well, let's count. 1, 2, 3, 4. 1, 2, 3. Well, 4, 3 is going to make this one true, but not that one. So this is a no. How about -2, 4? -1, -2, -1, 2, 3, 4. It's in the solution area. How about 0, -4? It's down here. No. How about -5, 6? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. It's on the orange line, but the orange line was solid. So yes, it is true. And just to show you that if it's on a solid line, it's a solution, let's do it. So I would do 6 is greater than or equal to the opposite of -5 plus 1. So this is 5 plus 1. 6 greater than or equal to 6 is true. 2, 4. Now with 2, now if I take this same point and I plug it into here, which I should do, I get 6 is less than -3 times -5 plus 1. 2 plus 2. So this is 15 plus 2. 6 is less than 17. That's true. So you see, this number satisfies both. This number will satisfy both. These two will not. They will satisfy one, but not the other. Okay? So that's how we do these. I'm going to come up with another way to do this one next. I'll show you. Maybe 2 different colors. I don't know. We'll figure it out. So, moving right along. For first inequality, I have m equal 1/2, or I could say -1 over -2, right? So this is up 1, right 2, down 1, left 2. And my y-intercept is 0, negative 2. It's dashed, and that's because of the less than, and it's below. Okay? Now, this one I got to do a little work, don't I? So I'm going to subtract 8x and minus 8x. It's going to leave me with 4y. Now I subtracted 8x. I did not divide by 8x, okay? Or by 8, a negative. I just subtracted. So nothing changes. And I get 4y is less than or equal to negative 8x plus 12. And now I'm going to come back and I'm going to divide by 4 and divide by 4 and divide by 4. This is not negative. It's positive. So nothing changes, okay? So I get y is less than or equal to negative 2x plus 3. So slope is equal to negative 2 over 1 or 2 over negative 1. My y-intercept is 0, 3. It's solid. And it's below. These are both below. So now we can graph. Okay, I got these split up like so. Let's do this one. 0, negative 2. 0, negative 2 is right here. And then up 1 and right 2. Down 1 and left 2. It's dashed. So I'm going to take my ruler and I'm going to make dashed line for inequality purposes. All right, now this one's below. Okay, so I'm going to use purple and I'm just going to shade like that. Okay, now if I picked 0, 3, negative 3, 0, negative 3 would be negative 3 is less than 1/2 times 0 minus 2. Negative 3 is less than negative 2. True. Okay? So I used a test point below. But if you write your inequalities like this and like this every time with y on the left, this tells you below or above, below or above. Okay? All right, let's do the next one. We'll do the next one in orange. Y-intercept is 0, 3, 1, 2, 3. Whoa. 1, 2, 3. I almost messed that up. And then I'm going to use my slope of down 2 and right 1. Okay? Or up 2 and left 1. You can go either way as long as you switch your directions on your rise and your run. And it's solid. This one is solid. So I'm going to make a solid line like so. Okay. And this one is also below. So I'm going to shade like this. And I see overlap right here. Right here I have purple and I have orange. So I'm just going to come back with a yellow. I'm going to go like this. And I'm going to make my solution set area. All right. That is my system's solution set area. Now I need to just check points. 0, 0. Let's just do this. If I plug in 0, 0 here, I get 0 is less than or equal to 12. True. Okay, so that makes the orange one true. If I plug in 0 here, I get 0 is less than negative 2. That makes the purple one false. So 0, 0, no. Okay? Now, I could have also just gone to 0, 0 and checked it and said, hey, is this a solution? And the answer is no. The reason it's no, and the reason when I checked this one, it was true for the orange is because here's all the orange. So the orange was true, but the purple was false. So now let's just go over here and check 5, negative 1. So 1, 2, 3, 4, 5, negative 1. That's right here. Okay, that's the point we're talking about. It will make the purple true, but it will make the orange false. So this is a no. Let's check 0, 3, -3. So 0, 1, 2, 3. That's in both. This is going to be a yes. Now, I'm not going to go write them all out, but if you doubt it, check it in both inequalities, and it'll make it true. -2, 1, 2, and 1, 2, 3. We're right here. We're on the line. We're on the line. What do you think? Is that going to make both of them true? One of them true? None of them true? Well, it's going to make the purple one true because it's in the purple one solution set area. It's not in the the orange. It's in the orange solution area because anything this way makes the orange one true, okay? Anything this way makes the purple one true, okay? Now, this is going to be in the orange. It's not in the shaded portion of the purple. It's on the line, but the line's dashed. So this is a big fat no, because it won't make the purple one true, because it's not less than or equal to. Okay? All right. One more thing to do for our notes today. Let's write these two inequalities. So before I do this, it might be hard for you to see on the video, I don't know, but I'm going to make it a little bit darker and let you see it a lot better. This line right here is definitely dashed, okay? If you printed out your notes at home, you probably can see that. This line right here, I'm going to turn my paper a little bit, is solid, okay? So just going to clean it up a bit. All right. Now, for the record, this is going this way. By the way, I usually show this, and I haven't shown it yet. I started to show it on that last one. Solution sets to the left. This solution set is down. So this is below. Okay? Why am I doing that? Well, this is solid, and it's below. So it's going to be a less than or equal to. This is dashed, and it's to the left. So it's going to be a less. Okay? See how I got that? Solid is the equals, and below is the less than. Dashed is no equals, and to the left is less than. Okay, so for this point graph right here, let's talk about this. You may just already know, some of you are on it, and you're like, hey, that's a vertical line. I know what that is. Good for you. If not, then pick specific points. Pick this point. Pick this point. I'm just randomly picking points and make a table, especially on a vertical or horizontal line, because it'll help you remember. So if I pick this point, it's 5, 0. This point is 5, 2. This point is 5, 4. I just happened to pick them 2 units apart. I could have picked, I could have picked this one and put in 5, 5. But here's my question. What is never changing? X. What is changing? Y. Okay, so what do we always know? We always know that X and 5, right? Well, we said less than or equal to, so less than or equal to. That is my first inequality, okay? That is it. Now, how about this one? What do we need for this one? We need to know the slope, and we need to know the y-intercept. Well, the y-intercept right here. Y-intercept is 0. Okay? Now, I just need a slope. Well, I picked up on that point right there immediately. And then I have this point. So if I draw my triangle, my run is 1 and my rise is 2. So my slope is 2 over 1. So my second equation is going to be y less than 2x plus 0. You can leave the 0 off, and that's okay, but you can also write it. So just to finish it off, x is less than or equal to 5, y is less than 2x plus 0. That is the system for this one. Okay, kind of getting on, catching on, I think. This one, if you printed it off, you should be able to see it. Mine printed fine, and I have older eyes than you guys, so no worries. If you should be able to see this, no worries. Okay, that one's dashed. This one, solid, solid. Okay, solid. This one, hopefully you see what I'm doing with these arrows. Hopefully it'll help you. Because look, the direction of the shading is up, right? So if the direction of the shading is up, that means greater than. So this is going to be a greater than or equal to, and it's equal to because it's solid. This guy's shaded down. So this one is less than. Okay? Now we have our inequalities. And we know this one's less than, we know that one's greater than or equal to just by observation. Okay, hopefully you're like, hey, this isn't so bad. Now, remember, for writing any equation, we can use y equal mx plus b. So when you give me the slope, when I can deduce the slope and I can find the y-intercept, I'm just going to go right here. But don't forget, we always have y minus y sub 1 equals slope times x minus x sub 1. Okay, so what do we have left to do? Well, here's our y-axis. And I look right here, and this guy has a b equal to 5. So 0, 5 is the y-intercept. Now, if I can just find slope, okay? Well, here's a triangle right here, and this is right 2 and up 1. So my slope equals 1/2. Yeah? Okay. My inequality is less than. So y is less than 1/2 x plus 5. If this looks easy, it should be, because you've been doing this kind of thing, writing equations for months and months, okay? So we know this one's a greater than or equal to. We just need a y-intercept. And it looks to me like -1, -2, -3, -4. Ooh, it's -5. Found it. So b equals -5. All I need is a slope. Can I get the slope? Well, I'm not, I kind of got in my way here. That's all right. I can see right here is a point, and here's a right triangle. So it's up 2 and left 1. Look at the minus for left, okay? So it's 2 over -1. It's equal to -2. All right, so y greater than or equal to -2x minus 5. Here's our system of inequalities for that example. All right, so I'm going to give you a bunch of practice on Math Excel this week for homework 1, and we'll talk about homework 2 in the next video.